Good morning, class. Welcome to yet another episode of Power Systems. And today we are learning about the elements of an electric power distribution system. My name is Francis Mongangi. So, the learning outcomes for this class are: the learner should be able to define a power distribution system. The learner should also state the elements of a distribution system. And finally, the learner should be able to describe the functions of the elements of a power distribution system. So let us define what a distribution system is. With me here is a diagram of a sample or an example of a distribution system. And as you look at the diagram, you'll notice that a distribution system transports the power from the transmission system or the substation to the customer. So as you can see here, we have a distribution substation and then we have the loads. So the distribution system will basically supply the power from the substation or from the distribution substation to the consumer loads. It is a system of wires and associated facilities extending between delivery points on the transmission and the point of connection to the end users. I've already explained that. So next, let's look at the elements of a distribution system. The first element is electrical power transformers. We also have instrument transformers. We look at the two of them in that category: conductors and insulators, isolators, bus bars, lightning arresters, circuit breakers, relays, capacitor banks, and miscellaneous equipment. Do not worry about the terms or the complexity of the terms. With time, we shall understand what each one of them are and their functions. So let us go direct to the first element, which is an electrical power transformer. So an electrical power transformer is a static device that is used for transforming power from one circuit to another circuit without changing its frequency. This is just the normal transformer that you see on the distribution lines uh, next to your houses. So the transformer is generally used to step down or step up the voltage levels of a system for generation and transmission purposes. So here is an example of a diagram of a power transformer. So these are just the transformers that you have met on the along the power lines. The second element, or let us look at the types of transformers. We have two of them, what we call the instrument transformers. They have two types. We have the current transformers and the potential transformers. The two of them are used for metering purposes. The current transformer and the power transformer are responsible to transform the current and voltage, respectively, to provide accurate reading for meters and acceptable level for the protection relays. One of the elements that we have already mentioned that is part of the distribution system is the protection relays. This one here. We'll cover it along as we go to the elements. So a diagram is here of a potential transformer, and then we also have another one of a current transformer. So class distinguish between the two of them. Take notes, and I want you by the next class to have the circuits or the power circuits. How do we draw a circuit of a potential transformer, and how do we draw the circuit of a current transformer? Please look at that before we meet in the next class. And then the next element are conductors and insulators. Conductors allow the flow of electric charge. They permit the free movement of the flow of electrons through them. And then insulators are just the opposite of conductors. They are metals which do not allow the free movement of electrons or electric charge. They resist electricity with a high resisting property. And then here we have both of them here. You can see we have a conductor. This is a cable. And then you have the different types of insulators. We have them here. Let's look at the next element, the isolators and the bus bars. An isolator is a manually operated mechanical switch that isolates the faulty section or the section of a conductor or a part of a circuit meant for repair from a healthy section. In other words, an isolator will remove the part that needs to be repaired and then leave the other healthy section continuing to provide power to the consumers. And then once the faulty area has been repaired, then the isolator will be reconnected, or the power will be restored in the area that was faulty. And then bus bars, they are conductors which carry current and have multiple numbers of incoming and outgoing line connections. Bus bars are just cables or the conductors that you see carrying power, and they're here. These are the bus bars. It's from here where they'll be connected to the transformers and the other components. So let us look at the next component, which are lightning arrestor and circuit breakers. Lightning arresters are placed to pass the entire lightning surges to earth, since all substation equipment are erected outdoor. In other words, the lightning arresters will, just from the word arrests, they are meant to protect all the other components, uh, to add them, or to ensure that all the other components do not get damaged, so that if they detect any lightning surges, then they are able to direct them to the earth. And then circuit breakers, they are used to protect the substation and its components from the overcurrents or overload due to short circuit or any other faults. And then we can see an example here. These are lightning arresters. I'm sure you have seen them installed. And then here we have the circuit breakers. Let's look at the next component, or the next element, which are relays and capacitor banks. So relays are used for disconnection of the circuits by manual or automatic operation. A relay consists of coils which, if excited or energized, to break or make a circuit connection. And then a capacitor bank is a set of many identical capacitors connected in series or parallel within an enclosure, and is used for power factor correction. When we learn about power factor correction, you will see how the capacitor banks work. And then we can see from the diagram here, we have a relay and then we have the capacitor banks. They are just many capacitors that are connected together. So that was the end of the lesson today. If you have any questions, you may please ask. Thank you.